Welcome to the multivariable calculus section. In this section we'll be discussing triple integrals. So now that we've learned how to integrate over two-dimensional regions, it is time to up the ante and learn how to integrate over three-dimensional regions. So it's important to note that a large portion of graphics deals with integrating over three-dimensional regions. In order to determine the volume of a three-dimensional region, we use the equation, the triple integral over the region E, f of x, y, z, dv. Now that is also similar to the triple sigma of NML, i.e. I, j, k is equal to 1 respectively over our function x, y, z. So essentially what we're saying is that this is also equal to the f, e, c, d, c, b, a, f of x, y, z with respect to dx, dy, dz. And that is essentially what our triple integral is. All it is a double integral with another integral. And that is as easy as it seems, because knowing what a double integral is, all you're doing is adding a component to it, another component, the z component. And it's not any more difficult than it would seem to be. So many of you are asking, why would you ever use a triple integral if you can find the volume using a double integral? But when we take the triple integral of a three-dimensional surface, essentially we're taking a point, an obscure point anywhere on, we'll say xi, yi, and zk, and we'll change this to a j for consistency. And we're saying that we want to integrate this point. And so we integrate that point and we are now given a box. And we are given the area of that box. Now, given this box, we want to find the volume of a cube or a rectangular prism. So we integrate again. And now, since we integrated, we found this box. That's one integration. We've integrated again, we find the area of that box, and we integrate another time to find the volume or of a rectangular prism. So essentially, we start with one obscure point, we build into this block, and we find the entirety of the blocks that make up that rectangular prism. So this allows us to take in and account for disproportionate mass, disproportionate density, disproportionate arrangements of these blocks. So if you ever get into mechanical physics that is increasingly difficult, you'll start accounting for different densities and masses. Additionally, in the double integral situation, we have to start with a box, and that box is similar to every single box around it. Otherwise, we wouldn't be able to calculate the volume. So rather than getting ahead of ourselves and talking about every single application of triple integrals, it is important to know that there is a distinct difference between triple integrals and double integrals. However, in multivariable calculus, there is not that much of a distinction. It's just for further applications. So that is it for triple integrals. I hope that helps, and if you need additional assistance, there's a bunch on the website. Thank you.